is called cost-effective lateral rehabilitation. The benefits of injection grouting for infiltration elimination. This is presented by Chris Hamilton with Avanti International and Mark Ankel with Logiball. This is a 45-minute presentation. Chris has been with Avanti International for over 10 years and has recently become the municipal division director. Chris has designed, written, and managed projects for the Tennessee Valley Authority, NASA, power plants in South America, and hundreds of municipal clients over the years. Lastly, Chris has lectured and educated numerous organizations and industry conferences on injection grouting technology in the U.S. and abroad. Mark Ankel started his career in Logiball in 1994 and served as president from 2004 to 2022, and most recently as head of technical sales through July 24. He has been involved with the development of ASTM standard practices, NASCO specification guidelines, active NASCO committee chair, board member, and past president of NASCO in 2008. Mark is actively involved in training at the municipal sewer grout schools and trained over 1,000 technicians. Guys, we're ready for your presentation.
Good morning, everyone. Let me get my screen up. Can you see my screen, Tim?
No, not yet. You're good to go.
All right, thank you. Well, good morning, everybody. It's kind of hard to follow Ryan because he covered so many of the points that Mark and I are going to cover as well. But so there might be a little bit of redundancy, but that was a good job, Ryan, and thank you for that. Thank you, Tim, for having Mark and I on today. Mark is we have the privilege of having him today because he has a lot of experience in this industry, and I've taken a lot of my guidance from him. So we'll jump right into it. For a lot of people in our industry, believe it or not, even though injection grouting has been around since the late 60s, early 70s as a mainline method of sewer rehab, it's still unknown to a lot of people in our industry. So I figure it first best to establish what is injection grouting, what are chemical grouts. So first of all, injection grouts, they're all kinds of different viscosities and some have expansion rates, some don't, some have high expansion, low expansion, polyurethanes, acrylates, acrylamide, etc. But at the end of the day, all injection grouts are liquids. They might have different characteristics, but they're all fluids when they're applied. And they turn from a liquid into impermeable solids in what we consider to be a predictable time frame. Target applications are sealing active infiltration below grade, like in our sewer systems, above grade, like in tanks and those types of things. Stabilizing soils and rock, controlling groundwater essentially, and then lastly, sealing the annular space between the hose pipe and the liner pipe, like Ryan just alluded to a little bit. I have a lot to tell you in this very short time, so forgive me if I go a little fast because Mark's going to follow right behind me. From our perspective, we kind of categorize our industries or our target applications in three different sections or three different sectors, that being municipal, industrial, and geotechnical. This is just a brief sample of a lot of the target applications that where injection grouting is used commonly. But our big focus today, obviously, is to the left of your screen and municipal. That being your main lines, laterals, lateral connections, manholes, wet wells, lift stations, et cetera, et cetera, et cetera. But there are a lot of other target applications where grouting is used. So specifically for injection grouting or remote packer grouting of laterals and lateral connections, the most common grout composition or chemical composition that's used are acrylamide and acrylics. And there's a few reasons for that. But to tell you a little bit about acrylamide and what it is, it's a two-component system. So it's a one-to-one system, if you will. It has the same viscosity of water, which is 1 to 2 centipoise. That matters when you are talking about using a remote packer and pressures. Mark will get into that a little bit more in a moment. It's a type of material that you can actually adjust your gel time or cure time and strength. It's really important because, as we know in the field, conditions change, things change. Like Ryan said a moment ago, you might go into do a top hat or T-liner in a lateral connection and find that you've got a lot of infiltration. You're going to have to speed up your gel timing. With acrylics and acrylamide, you can do that. It's not activated by moisture. When I say 1-to-1, I mean that it's chemically activated. When A and B come together, you've got magic. Successful track record, just meaning that, as I mentioned right in the offset, the acrylamide grout's been around since the late 60s, early 70s, and been used commonly in sewer rehab since then. That's a lot of back history, so that's good. It has, the question always comes up, well, okay, grouting looks like it works great, but how long does it last? Which is it's a relevant question, right? It's a valid question. And Department of Energy did some testing back in the 70s on the longevity of acrylamide at a 20% concentration. Different target application, that was to encapsulate radioactive waste, but their determination was that at a 20% concentration, acrylamide has a 362-year half-life. Most of us will be retired by then. It is used in sewer pipes, mainline joints, circumferential cracks, lateral connections, etc. And there is now, just over the past year or two, there is now a potable water version certified. I'm sorry, let me say that again. Potable water certified version of the acrylamide grout. The next family or subfamily of grouts, if you will, are polyurethanes. Polyurethanes are used more in man entry type situations, such as wet wells, lift stations, manholes. Within the polyurethanes, you have two subfamilies. You have hydrophilics and hydrophobics. And truthfully, outside of their base chemistry, they're as different as night and day. So hydrophilic polyurethanes are typically, or almost always, single component. They react with water. They're purely water activated. Hydrophilic is just, think about the Latin root of philia. It has an affinity for or a strong love for water. The expansion rates on hydrophilics are usually between 400 and 600%, roughly. They always cure flexible. And that's important because when we're talking about manholes that are subject to a lot of vibratory forces or dynamic environments in the street, we need something that can accommodate movement. And a flexible product is obviously what makes most sense. And most all hydrophilic polyurethanes are also NSF 61 certified for use in potable water applications. On the other side of that, okay, you have your hydrophobics. Hydrophobics, again, very different. They're generally also pumped as a single component, but they use a catalyst. A lot of people say, well, I don't like hydrophobics because there's just an extra component. That's a fair argument. But by using a hydrophobic with a catalyst, it allows you to manage or modify your reaction time. And again, like I said, with the modifiable gel time of acrylamide and acrylics and acrylates as well, conditions change. You go to one manhole on a project, maybe you've got very minor infiltration, your standard catalyst rate will work just fine, right? You go to the next manhole and you've got massive infiltration, 20, 30 gallons per minute. And so you're going to have to accelerate your reaction time to catch up with that infiltration, right? Your hydrophobics, unlike hydrophilics, have high to extremely high expansion rates from 1,500% all the way up to 5,000% and slightly more, actually. Your hydrophobics are a little bit more versatile in the sense that they can cure to be flexible or they can cure to be rigid, depending on which product you're using. And just like everything else we've talked about, there are NSF 61 certified versions of almost all hydrophobic polyurethane injection resins. Say that 3 times really fast. All right. So, and again, Ryan touched on this, and I'm glad he did. Why do we care about controlling infiltration? But first, let's define what is infiltration. A lot of you are familiar with the phrase or the acronym I&I. And we all kind of know what that means, but you'd be surprised at how many people don't know what I&I actually means or what it stands for and even further, how to define the difference between inflow and infiltration. So inflow is surface water. Imagine you've got a manhole in the street, you get a rain event and water seeps in around the frame and cover. That's inflow, that's surface water. Infiltration, which is more where we live, is groundwater that enters the system below land surface. Okay, that's the definition of I&I. And it's a big problem. It doesn't matter whether you're in San Diego, California, or Sanford, Florida. Infiltration is an issue for every utility. According to EPA, and this is an EPA number, not a BMC number, infiltration and inflow represents about half of all treatment volume any city USA. Any city USA. It's actually 47.8% to be exact. Now, if you're a small system that has 300,000 gallons average daily flow, okay, then you say, well, it's about 145,000 gallons a day. It's a lot. But what if you're a city of Los Angeles or a city of Miami-Dade? Now you're talking about 300 million gallons a day of average daily flow. So roughly 140 million gallons a day is active infiltration and inflow. That's a lot. And that's a cost that we are all collectively trying to reduce and eliminate. So why control infiltration then? Well, as you know, in geology, we know that loss of fines is a real scenario. When you see sinkholes or washouts in the road, it's not because soil just goes bad. It's typically because there is a root cause, and that's often, usually 8 to 9 times out of 10, that's caused by underground infrastructure. When you have groundwater infiltration in any structure underground, it could be a curb inlet in your storm, it could be a manhole in your sanitary, it creates a vacuum, and that vacuum sucks in soil fines. Well, if it's in the middle of a street, eventually the asphalt's not going to hold the road up anymore, right? So you will have sinkholes and washouts. That's costly. That adds cost to, now we're not just talking about treatment volume and treating that volume of clean groundwater. Now you're also talking about road repairs. Also, as many of you know, some of you work in utilities, and that's great. Every utility has an allowance of SSOs, but exceed that allowance. And now you've got to deal with the federal and the state EPA, EPD, all right? To reduce costs and the operation and the maintenance of the collection system. Think about it. If you have a plant that's designed to do X every day, but you're asking it to do Y every day because you're not maintaining or you're not reducing the infiltration in your system, that's going to increase your cost, the whole system, all right? To reduce treatment costs in the wastewater, think about the more you treat, the more you pay, and really, the more you and I pay, right? As a utility, of course, they're paying to treat it, but the ratepayer is ultimately the one that bears that burden. And then to extend the life of the collection system for future generations. Surely you can understand that it's not just our manholes, wet wells, main lines, lateral connections, etc., but also, again, roads. As of 2021, the ASCE report card grade for our wastewater system, this is only in the United States, is a D+. Isn't that crazy? We're one of the most advanced societies in the entire world, and yet our wastewater system is graded at a D+. Our storm system is graded at, I think, a D. So our storm system is actually about the same as our sanitary sewer system. Okay, so again, our focus today, acrylics and acrylamide for laterals and lateral connection grouting. All right. The system here, and I'm not going to talk much about it. This is the remote packer system for lateral connection grouting. Mark's going to talk more about this in detail. But this is basically what we're looking at is 2 bladders. These 2 yellow bands represent bladders. These are inflated to create a closed environment around the lateral connection. This is called a lateral sock that's inflated. That in turn creates a closed environment. And then, and then over here you have a camera. Just to let you know that this system is employed from what is, I kind of call it a glorified TV rig or camera rig, CCTV rig, because what you've got is a CCTV rig as the base equipment, but you got the added apparatus of the remote packer system. And to the left of this picture, you'll see a little bit of the camera. So that is to say that when you do lateral connection grouting, The operator sees everything real time as it's being done. He or she can make notes. They can center up on the lateral connection of the mainline joint. Everything is being recorded via CCTV. All right. There's a lot of, and you're going to hear about it all today. There's a lot of different tools or technologies. I kind of put them in the same group when it comes to lateral connection rehab or lateral grouting or lateral rehab in general. There is dig and replace. As Brian mentioned, a lot of these top hats, T-liners, point repairs, the CIPP technologies. All of these things have something in common. It is that they were designed to be structural remedies. And so you say, well, how is that? Well, if you ask anybody who specifies or installs liners in mainline pipe, they'll say it's essentially a new pipe within a pipe because they were designed to be structural remedies. Injection grouting is not designed to be a structural remedy. Does it add some strength to the bedding soils? Absolutely. But ultimately, injection grouting was designed with one purpose in mind, and that was to eliminate active infiltration. And again, I know I keep going to Ryan, but he actually hit right on this. Some of the best lining companies in the United States know that if they have active infiltration, that pre-grouting has to be performed. Because when you try to insert a liner or a top hat or a point repair with active infiltration, all kinds of bad stuff can happen. Resin washout, bellied liners, et cetera, right? And ultimately what it leads to a lot of times is that the lining contractor has to go back and cut that out because the utility is not willing to accept a defective liner or a defective top hat or T-liner. All right, so a lot of times grouting is needed before lining can be performed. And a lot of times what we've found over the years is that a lot of utilities have infiltration issues, not structural failure, and they want to line anyway. And sometimes we say, look, if you just have infiltration issues, then maybe you need to consider one technology or one tool instead of the whole combination of tools, right? All of the lining technologies do a great job establishing that new pipe within a pipe, a structural remedy, but they're not designed to be remedies for active infiltration. So when people say, well, you guys compete with the lining industry, not at all. We are complementary tools or technologies, and your job is to know when to apply what tool. You wouldn't try to tighten a hex head bolt with a flathead screwdriver, right? So as a standalone process, injection grouting can be its own tool, its own technology in structurally sound lateral connections. Structurally sound. So in other words, you're looking at it, you don't see any significant breaks in the pipe or you don't see a collapse in the clay pipe. You just have infiltration. Grouting can be a standalone process. And injection grout seals around lateral connections where they join the main sewer system to prevent groundwater from entering through gaps, cracks, or faulty seals. If every tap was perfect, we might not be having this conversation. But those of us who've been in this industry a little while know that hammer taps often leave a pretty messy situation, right? So you're going to have gaps, you're going to have cracks, you're going to have leaks where groundwater is able to come in. So one of the benefits of using grouting as a standalone process is that it provides a more durable and leak-proof connection, which prevents infiltration, which we're trying to eliminate in the system, as well as accelerate infiltration during rain events. We all know that many of us that watch flow data at different plants and utilities, we know that during rain events, you can see spikes of daily average flows 3, 4, 5, 6, 7 times, right? And that swamps a system literally, right? It's a relatively quick and cost-effective method for sealing leaks and preventing further infiltration. Before lining, we kind of talked about this a little bit just a moment ago. Injection grouting works in conjunction with, as another tool to CIPP liners and coatings, etc., by grouting before lining pipes to achieve an infiltration-free environment. These are complementary tools. By combining the methods of rehab and I&I reduction strategies, systems can greatly reduce the amount of infiltration used by leaking laterals and lateral connections. Additionally, lining technologies can be applied effectively without active infiltration so that the lining contractor can be confident that this liner is going to cure out correctly and the utility is going to be satisfied with what we've done. All right. So I want to show you a video, if I may, real quick. I'm just going to get out of this and into this. Oops. Hopefully you can see this. I want to play you just a brief video of how lateral connection grouting works. So just to pause it really quick. Tim, can you verify that this is being seen? I just want to make sure.
It's not in presentation mode. It's just your PowerPoint is up.
Okay, shoot. Bear with me a bit. I had a video teed up that I really do want to share with you all. Okay.
You might have to share a different screen or
Yeah.
share the video program.
Well,
Maybe unshare, Chris, and then share back.
okay, let me try that.
Yeah, that might work.
All right, wait, here we go.
Yep.
All right, you saved the date. Thank you, Tim. All right, so earlier I mentioned that the grouting rig is essentially a larger CCTV rig, and this just gives you a little snapshot of that. You've got your 14-foot box, as you would imagine, but this is going to be an 18-foot box to make room for all the apparatus that you need on the back. So the lateral connection, and again, I'll speed through this because Mark's going to talk about it in detail. We've got our system. This is an unlined pipe. Okay. The remote packer is in the line. This is a winch to your right. Here's your camera to the left. That operator is seeing everything real time. They're going to move that remote packer into place. They're going to inflate the two bladders that I mentioned earlier. That creates that closed environment. Then they're going to inflate the lateral sock. That creates another closed environment. Inject grout, air test. If it passes, great, we move on. If it fails, we inject another phase of grout. Like Brian mentioned earlier, air testing is sometimes necessary, right? So I will get out of that. Go back to this. Slideshow concurrent. All right, so injection grouting after lateral reinstatement. Again, sometimes lateral reinstatements are messy. They're ugly, and they create pathways for groundwater infiltration. So injection grouting works in conjunction with technology such as CIPP liners. I think we have established that. Grout first to stop infiltration, line second for structural repair. Time and money. A survey conducted among several contractors. We ask questions a lot because we need to know. But in surveying some of the more experienced contractors that put in top hats, T-liners, lateral connection liners, we asked how many of these can you do a day in a good day when everything is going right? They said to us collectively about 3 to 4 per day. Average cost of a top hat or T-liner system ranges between $2,500 to $7,000 each. And if structural issues are present, that cost is absolutely justified. If the lining system fails, the remedy is generally dig and replace. And bypass pumping is generally required for all lining applications. Again, we're trying to avoid water. Similar analysis determined that 10 to 15 lateral connections can be grouted in a good day and sealed in a single work day. Bypass pumping is sometimes not required. The average cost, at least present day cost, to grout and seal a lateral connection is between $500 and $900 each. If grouting is not performed correctly and it fails in, say, 2 years, then the remedy is go in and inject more grout because maybe they didn't get enough in there. Okay. So we, at our grout schools, seeing is believing, we like to do a lot of hands-on physical demos. And you can see to the left, it's one of my favorite pictures. I said that grouting is not a structural repair, but that it does stabilize and strengthen the bedding soils around the main or around the lateral connection. And the picture to the left is kind of testament of that. Right. On the right, you see the video. That's one of Mark's. I love this demo model. He stands it straight up. Everybody really test it to see how grouting lateral connection works. See what happens in the soil. That's very important. Okay. Documented success, when you think about something that's been around for 50 years in the industry and being used actively, there's certainly a lot of case studies and articles that have been written. A lot of utilities have had success with lateral connection grouting, both as a standalone and as part of a combination with lining technology. So my poll question to you is, and Tim, I don't have this. There we go. Poll question is, what is your level of experience with lateral grouting application specifically? That would be none, or you have a basic understanding. Perhaps you've been involved with lateral grouting applications, but you want to know more, or you do this or specify this on a daily basis. You have a high level of proficiency, experience, and understanding. Right. So some of you have no experience with this, and that's good. I'm glad you're here. Basic understanding. I hope we move the needle forward a little bit. Somewhat involved with lateral grouting applications. Like to know more. That's good. That's about 17%. And the smallest percentage of you are doing this or specifying this as a regular practice. So it's a good mix. It's a very good mix. All right. So with that, I'm going to hand it to the one and only Mark Anktel from Logiball. Mark, floor is yours.
Thank you, Chris. Let me share my screen. Replace current share. Is that working out? I guess so.
Yes.
All right. Okay. We're gonna have to do this quickly. So just want a few notes here. Back in the early 90s, most people were saying that infiltration was coming from the main lines. As we've done work through these over the last decades, that groundwater doesn't disappear. Basically, it's going to move to the connections, up the laterals, and manholes getting up higher. And we have to address these things now. So testing and sealing lateral connections and a predetermined distance up the lateral. Ryan said it earlier. If you're going further up, you're going to have to do some work before you attempt any rehab or grouting work or other. So you need to know with CCTV cameras, cleaning, etc., depending on the distance that you're going to go up the lateral. So lateral packers, basically, they're inflatable molds. We're going to launch a lateral grouting plug up in the service line. We always monitor what's going on with the pan and tilt from the main line, at least to be able to line it up. So the bladder is basically inverted from the main line assembly. The last portion of the bladder is actually going to go up and seat up against the lateral pipe. So we've got a 3-point seal or seating to be able to isolate the connection and a predetermined length up the lateral. Now, while this is inflated, we can't see anything. So we need to monitor what's going on in between those two inflated bladders. So there are sensors on the packers that give us the pressures of what's going on beyond our site, whether it be air testing or sealing and injection pressures. And we can monitor these with a pressure gauge at the end that with camera is going to be looking at, so we know what's going on beyond our site. That data can also be used to transmit into the CCTV grout truck with a transducer. And with lateral packers, it's always better to use a transducer than a gauge, even though a gauge can be used. So the above ground setup is basically you got the truck, you got the manhole winch at the other end, you've got the lateral packer assembly, all the hoses, the extensions, the camera. In the right-hand side picture, you've got an effective sealing distance. In this case, it's about 18, 20 inches. So any defects, non-structural or structural in this case, where groundwater is allowed to migrate into the sewer, we can pump grout out under controlled pressure and monitored pressure into the soil on the backside of the pipe. Prep procedures, I think Ryan went through this. Great work, by the way. You need to know the diameters, you need to clean the mainline sewer. If you can't seat the bladders or get the equipment through, it's going to be very difficult for those rubber bladders to seat correctly against the pipe and be able to perform an air test and or seal. So identify the diameters, protruding taps have to be removed. Nice to know the number of laterals to test and seal within a reach. Roots, grease, any other debris that's going to prevent the passage or seating the equipment, it's got to be addressed. Bypass pumping, normally not an issue as we're only inflated for a short period of time. But if you can't see what you're doing, you need to control the flows. That might be bypass pumping, plugging, whatever the proper application may be. So typically, like we saw in the video, we're going to bring that packer to the service connection. We're going to rotate it. We're going to line that orifice with the service connection and invert the lateral grouting plug out of the assembly into the lateral. So now we've got a 3-point seal up in the lateral and on each side of the T or the Y. We can perform an air test. If it fails the air test, everything stays in place and we start the pumps and we monitor the injection pressures. We're pumping liquids that eventually turn out and react into a gel. So we are going to see increases in pressure as we are pumping, and we have a change from a liquid into a gel on the backside of this. Gel times have to be long enough for the materials to get out into the soil and seal and stabilize that soil. So once we've grouted, we can perform a post test to confirm the repair. Then we deflate that lateral bladder, vacuum it back into the mainline part, have a look with the pan and tilt, and move on to the next connection and repeat the process. So plexiglass pipe shows you how this is done. You've got the lateral, you're inverting it up in the lateral pipe. If you miss, it doesn't matter. Try again. There's no liner, we're not injecting yet, etc. So anything that's between the connection and up to the blue line in this case will be tested and sealed. So you see the materials, they come out at the mainline part, they fill up this, I'll call it pizza form or whatever, and we're pumping, and we're finding defects to allow the grout to escape from the pipe into the soil. It's important to use the right bladder so that we leave residual grout left in the lateral. There's bladders for 4-inch and 6-inch. On the right-hand side, you see a picture from a clean out from what kind of residual material we can leave in there when using the right plug. There will be residual material. You're being asked to seal an effective distance up in the lateral, so that grout has to reach that distance. But using the right plug and the right procedures, residual grout will be left in the lateral, and as the homeowners are building, flush, take showers, etc., that will eventually fall back into the mainline part. So you're seeing residual grout. Here's the connection. You got your pan and tilt camera. Then looking up and you see all the dimples. That yellow bladder is placing an inflatable mold, so the residual material will have those little dimples in it. You've got void volumes. For operators, it's important to know what those volumes are between the inflated packer and the inside of the pipe. Knowing this will give them an idea of what's going on and can also be useful for the engineers of municipalities for bid and specifications. Lateral connections after lining. Lining is a great process. Problem is water finds its way back. If it's not in between the hose pipe and the liner, it'll be up in the lateral joints or breaks up in the lateral section. So we make holes in liners. Of course, we want to service the people using the laterals, okay? So groundwater finds its way back in. After lining, grouting, the viscosity of the materials being pumped are so low that they will push out the water. We will find paths where water finds paths. We will replace that water with gel grout. That gel grout will travel out through those hose pipe defects where it is allowed to come in into the soil, seal and stabilize the pipe bedding. Here's a little example we do at the grout schools. We have a sample CIPP in PVC pipe. We just put a mainline packer over it. In this case, we're pumping dyed water. So that dyed water, in this case, finds its way in that very small annular space. It will go out into the soil to seal and stabilize the backfill materials. Outside drops, 8-inch. Physically, somebody goes in the manhole and positions that packer. There's just too much bladder in this diameter, 8-inch mains, to be able to invert in and out, so it has to be physically positioned. When you get to 15-inch and up, packers are flow through, do allow some of the flow to go by, and we have bladders up to 8-inch diameters. Here's an example of the bigger packers and the setups. You always have your pan and tilt camera in the back end to see what's going on in the main line, and flow through capabilities on 15-inch and up. So poll question number 2, we're grouting laterals. Connections from the mainline sewer after reinstated mainline pipes. You only seal the annular space. True or false? I guess you're good students. Okay, so yes. Now, depending on what is being specified, if you say I need to seal 6 feet of lateral from the main line, 10 feet, 3 feet, 2 feet, anything within that reach should be sealed. So half and half, you're not only sealing the annular space, it's still going on here. So we're about 57 for false. It all depends on what you're being asked to do, but annular space and all the defects up to where that bladder sits up against the pipe. All right, I'm going to end this and move on. Right. Next slide. If I can move. Okay. You get into situations where main line is over 36 inches in diameter. Well, we can't put a packer in there. So there are tools that exist with man entry situations where we can jack up the plate up against the side of the lateral and physically handheld lateral bladder into the lateral to seal the lateral. You've got examples here. This is after CIPP, they reinstated the services. Operator basically hand directs the bladder into the lateral, jacks the plate and the bladder, starts injecting and seal off that infiltration. Now, from the mainline sewers, you've got different capabilities. Main lines anywhere from 6-inch to 30-inch, remotely operated. Sealing distances up to 30 feet have been done successfully without any access to the clean outside or homeowner side. Different diameter lateral plugs to accommodate different diameter laterals. Now, pushbackers from a clean out. Sometimes you can do the connection, but maybe wise or 2 laterals coming in, so you may have to use a pushbacker from a clean out side. So our clean out access allows us to be able to push with the help of a mini camera and semi-rigid hoses, a sausage packer, which is flexible, where the 2 ends expand up more than the central portion, isolating the joints. So testing and sealing can be performed on these things. You've also got laterals connected to manholes. So you could use a flexible pushbacker and do 1 joint at a time or 3 foot in between those 2 seals, or decide, hey, I'm going to use a longer sausage where the tip or the end expands more. And I'm going to test and seal in 1 injection, 10, 15, 20, 30 feet of the lateral, depending on how long that bladder is. So somebody feeds it down the manhole, another operator feeds it into the lateral, pushes it in, semi-inflated, and isolates 10, 15, up to 30 feet of the lateral that can be injected for the ones connected to the manholes. There's a paper from NASCO, test cell grouting research white paper. I encourage you to read it if you get a chance. It's great. It gives you a lot of information on, hey, we're not just sealing the joint, we're sealing the soil and, changing the bedding conditions behind the pipe. Chris showed you earlier, we do these demos at grout schools. Basically, we're going to take a PVC pipe and create a defect in it, backfill it with sand, gravel, whatever's available to us. And that grout travels in between these pores. I'll give you an example. We use sand, you have 30% voids in sand. Well, we're going to push that material into the voids in the sand particles, that 30% void in sand, and basically consolidate everything. So grouting laterals basically seals connections, anything up to the end of the bladder, and we're changing the bedding conditions. Tim?
All right. Thanks, Mark, for taking time out of your retired life to present. Very good information. Grout and lining, that goes together. I appreciate you both participating. If you have any questions for Chris or Mark, please use your Q&A button and type out the question. Again, make sure you indicate that the question is for them. We will answer these questions during our first Q&A session, which will begin at 11:20.